Above you right now, a beam of invisible light is sweeping the sky. It cannot be seen, it cannot be felt, but it touches every plane within 200 miles, and each one answers back. This is radar. It finds objects in darkness, in fog, in storms, using nothing but radio waves and a stopwatch. Today we slice one open, because the trick inside is simpler than you think, and stranger. Start with the problem. Your eyes see by catching light that bounces off things. But light gives up easily. Fog scatters it. Night removes it. Distance swallows it. A pilot in clouds sees nothing but grey. So engineers asked a simple question. What if we made our own light? Not the kind eyes can see, a longer wave, a radio wave, one that sails through cloud and rain and darkness as if they were not there. The word radar is an acronym, radio detection and ranging, and it begins with a shout. Deep inside the radar sits a transmitter, a device called a magnetron, or its modern cousins, that builds an intense burst of radio energy. The burst is short, around 1/1,000,000th of a second, but it is powerful. Some radars push out 1,000,000 watts in that instant. A shout of invisible light fired into the dark. A shout in all directions is wasted, so the radar focuses it. The pulse is fed into an antenna, often a curved dish shaped like a cupped hand. The curve does for radio waves what a flashlight reflector does for a bulb. It gathers the energy and throws it forward in a narrow beam, just a degree or two wide. Now the radar is not shouting into a room, it is whispering down a hallway in one exact direction. The pulse leaves the dish at the speed of light, about 186,000 miles every second. Read that again. In the time it takes you to blink, the pulse could cross the Atlantic Ocean and come back. It punches through fog, rain, and night without slowing. Radio waves are too long to be scattered by tiny water droplets, so weather that blinds your eyes is glass to a radar. The beam races outward, hunting for something solid. Then the beam hits something. A plane, a ship, a flock of birds. Metal is the best mirror. The radio wave strikes the aluminum skin of an aircraft, and a tiny fraction of its energy bounces back the way it came. And tiny means tiny. Of that 1,000,000-watt shout, the returning echo can be weaker than a trillionth of a watt. A whisper of a whisper, but it is enough. The echo races home at the speed of light. Here is the elegant part. The same dish that shouted, now listens. A fast switch disconnects the transmitter the instant the pulse leaves and connects a receiver, an amplifier so sensitive it can raise that trillionth of a watt into a clean signal. The radar spends almost all of its life in silence. It shouts for 1 microsecond, then listens for 1,000. Like a bat in a cave, it lives between the call and the echo. Now the stopwatch. The radar measures the time between shout and echo, down to billionths of a second. The math is simple. Radio travels about 300 meters in 1/1,000,000th of a second. So if the echo returns after 1,000th of a second, the pulse covered 300 kilometers out and back. Halve it, and the target sits 150 kilometers away. Distance measured not with a ruler, but with a clock. Distance is half the answer. Direction is the other half. The dish knows exactly which way it is pointing, so any echo it hears must come from along that line. To cover the whole sky, the antenna rotates. The slow, hypnotic sweep you see at airports, turning around 5 to 12 times each minute. Each rotation paints a full circle of echoes. Distance from the clock, bearing from the dish, together they pin the target to a map. Radar can do one more trick. It can feel motion. When an echo bounces off a target moving toward the dish, the returning wave comes back slightly compressed, its frequency nudged higher. Moving away, the wave stretches and the frequency drops. This is the Doppler effect, the same shift that bends an ambulance siren as it passes. Measure that tiny change in pitch, and you know the target's speed, without ever watching it move. There is a catch. The world is full of echoes. Hills answer, buildings answer, rain answers. A raw radar screen would be a snowstorm of returns, with one faint aircraft lost inside it. So the radar filters, Ground clutter never moves, so anything with zero Doppler shift gets erased. Echoes are compared sweep to sweep, and only the ones that travel steadily like an aircraft survive. The computer keeps the movers and quietly deletes the world. Run the whole chain one more time. The transmitter builds a fierce microsecond pulse of radio energy. The dish focuses it into a narrow beam and fires. The pulse flies at light speed, strikes a target, and a faint echo returns. A switch flips the dish from shouting to listening, and the receiver amplifies the whisper. The clock turns delay into distance, the dish angle gives direction, the Doppler shift gives speed. And the filter erases everything that stands still. Shout, listen, time, repeat. Next time you pass an airport and see that dish turning, slowly, patiently, remember what it is doing, shouting in light you cannot see, timing echoes you cannot hear, drawing the sky one whisper at a time. The world is full of machines like this, quiet, exact, and almost invisible. We will keep slicing them open. Thanks for watching The Cutaway.